Welcome back everyone to this lecture where we're going to discuss an intuition behind the key hyperparameters for dbScan. As we've seen already, there are really just two key hyperparameters for consideration when working with dbScan, and that is epsilon and minimum number of points. And recall that epsilon is going to be the distance extended from a point to begin the search for the minimum number of points, where the minimum number of points is the minimum number of points within an epsilon distance in order for that point to be considered a core point. And you can review our theory and intuition lecture on the different types of points, such as core point, border point, and outlier. Now, adjusting these two particular hyperparameters that clearly have a relationship between each other usually results in two main outcomes, which is going to be the changing of the number of clusters discovered and also changing what is an outlier point. For example, here we can see an example dataset with two distinct blobs, but we also have in between them three clear outliers to the human eye. But if we were to run dbScan in scikit-learn with its default settings, you would notice that it would actually discover 6 outliers, even though we probably want those 3 outlier points in the bottom left to be part of cluster number 1, or the green cluster. So eventually what we'll have to do is figure out how to adjust epsilon, for example, in order to identify just those 3 in-between points as outliers. So we can see here, based off the labels, we have cluster 0, cluster 1, and then 3 outliers that are clustered as -1, which is to say they don't belong to any particular cluster. dbScan has labeled them as outlier points, neither border nor core points. Now let's get an intuition of epsilon. Increasing epsilon allows more points to be core points, which also results in more border points and less outlier points in general, because epsilon is the distance you are searching for within a range or neighborhood to consider points for a minimum number of points. One of the easiest ways to get an intuition for key hyperparameters is to think of them in the extremes. For example, let's imagine that we were beginning our dbScan and hopping from point to point, and we were considering a huge epsilon, just a very wide radius or range to begin for consideration of minimum number of points or minimum number of samples. Then with a huge epsilon, that means you have a lot of points that are within range or within the neighborhood, which essentially means that eventually as epsilon grows larger and larger, you're going to begin classifying everything together into the same cluster, since they're all within the same neighborhood because you gave such a large range for epsilon. That would be increasing that expanding circle from that point you're considering for core, border, or outlier. Likewise, decreasing epsilon causes more points not to be within the range of each other, which would create more unique clusters. And you can imagine an absolutely tiny epsilon, that is an epsilon that barely extends past a point, which means the range would not extend far out enough to come into contact with any other points, and you would begin to give that point its own unique cluster and not even an outlier because it's not actually being connected to other points. So you'll see that as you increase or decrease epsilon, you're essentially changing how many clusters you'll actually end up having. So there are methods for finding an epsilon value, and typically what you do is you run some sort of elbow or knee method, that is plotting multiple values against some sort of distinct measure. For example, we could run multiple dbScan models with varying epsilon and begin to measure number of clusters, number of outliers, or percentage of outliers. Keep in mind that it's going to be extremely dependent on the particular dataset and domain space to have an intuition over what a correct number of outliers or percent of outliers or number of clusters is. And this typically requires the user to have some expectation or intuition about the number of clusters and relative percentage of outliers. There's no easy way to immediately figure out the correct epsilon. Even when you're charting it out, it will depend on domain experience from the user. But typically what this looks like is you're going to plot out either an elbow plot or a knee plot, that is a diagram, that is going to compare the results for different epsilon values. So we can see here on the x-axis, we're starting from an epsilon value of 0 and going all the way up to 1. And on the y-axis, we have the number of points that are being classified as outliers. And obviously, as you have a 0 epsilon value, that means you're not checking anywhere past the range of a particular point, so you have a bunch of outliers. Essentially, every point is going to be its own distinct outlier. But as you increase epsilon, you're increasing that range for the minimum number of samples or minimum number of points that you're allowing for the classification of a core point or a border point, and you should see the number of outliers go down as you increase epsilon value. But if you increase it too much, then everything's going to belong to the same cluster and there will be no outliers or distinct clusters. Now let's discuss the minimum number of samples, or points. Number of samples in a neighborhood for a point to be considered as a core point is the definition of minimum number of samples. And keep in mind that this is going to include the point itself. Increasing to a larger number of samples needed to be considered a core point causes more points to be considered as unique outliers. So imagine if the minimum number of samples was really close to the total number of points available. Then it would be very likely that all points would become outliers, because there's not going to be enough points within range because your minimum number of samples is just way too high. So how do we actually choose the minimum number of samples? Essentially the same as epsilon. You'll test multiple potential values and chart against number of outliers labeled. So for example, here we can see on the x-axis, we're increasing the minimum number of samples for a point to be considered a core point. And as we increase that threshold of that minimum value, then more and more points are going to be classified as outliers until the minimum number of samples would basically be equal to the number of points available, which means everything is just going to be classified as an outlier. So keep in mind that sometimes it's actually useful to increase the potential of the minimum number of samples to discover new small clusters instead of complete outliers. For example, we can see here the 2 blobs and 3 points example from before. With the right choice for minimum number of samples, you would actually not label these as outliers, but you would label them as their own unique clusters. So sometimes it's best to mix and match epsilon and minimum number of samples along with your domain expertise if, for instead of those 3 points being outliers, you actually want them to belong to their own single point clusters. Okay, let's continue all of this by exploring these hyperparameters with code and data examples. I'll see you there.